Okay, I know I'm doing these not 2 days ahead of time, but just one day ahead of time. But I've got to tell you, I've only got so many hours in my day too. So, but we'll make this kind of painless. All right, I want to kind of go slow here, and I know we're just covering the first part of chapter 16, but the second part, 16.3, I kind of skip over 16.4, and because that's the dielectrics, and it's cool stuff, and it shows why how we build capacitors a little bit. But in 16.5 is pretty easy algebra, but the problems aren't hard. So I've only assigned 5 problems for between now and Monday, and then I'm going to probably on Wednesday assign 4 or 5 more that cover the end of chapter 16 that'll be due a week from, or maybe even a week from tomorrow, a week from Wednesday. So you'll have like 10 problems due over this week, but we need to kind of move on. But I think we're stuck. I think we're a little bit stuck. I can just tell that you all are a little bit funny on how things are working. So, or what is this voltage? What is this electric potential? Well, basically, what electric potential is, it's the an electric field. A charge creates an electric field. Okay, so here you go. Here's the deal. This positive charge creates an electric field. Okay. Now, the further out I get from this electric field, if I drew it in vector formation, okay, here's my electric field in vectors, and the further out that I got, the weaker these vectors become at each point, okay? And so, but this electric field produces but this charge produces these electric fields. Now, it also produces, around a charge, you have an electric potential, okay? So let's say this is 1,000 volts here. And then we come up here, and then this one would be, let's say, 500 volts here. Okay, and then it's sitting over here, and this becomes negative 100 volts. Now, let's say, for the sake of argument, that I'm a negative charge here, out here, and I'm free to move. I am free to move. So I'm at negative 100 volts, and out here, perpendicular to the electric field, is negative 500 volts. Okay, this line is negative. Okay, so if I'm a negative charge, here's what voltage does. I go, oh, I want to go from now this electric field, which is pointing this way, the E field is pointing this way. There isn't a voltage field, it's just a ring around, but this charge wants to go, if it goes from here to here, what did I say, that was 500 volts? So it went from there to there, so it goes from here to there. So it went from negative 100 volts to 500 volts. So VA was equal to negative 100. VB was equal to positive 500. And let's say this charge is negative 2 microcoulombs. Okay. What was its change in electric potential energy? Well, the electric potential energy change is equal to Q times its change in voltage. And its change in voltage, as Sarah pointed out in class, she goes, hey, you taught us that you go from VB to VA. You are so right. So we'll take negative 2.0 times 10 to the negative 6 charges times B, which is 500 volts, minus negative 100 volts. And look what I wind up with. I wind up with a negative 2.0 times 10 to the negative 6 times a positive 600 volts. Well, then my electric potential energy is negative 1200 times 10 to the negative 6 joules, or 1.2 times 10 to the negative 3 joules, negative. And it lost charge going from there to there. Okay? It didn't lose charge. It lost electric potential energy going from those 2 points. Okay? All right, so that's what electric potential does. All right, so that's our intro to today. Then I'll go through some slides here real quick to prepare us for Wednesday.